Example 1. Use the properties of logarithms to find the exact value of each expression. Do not use a calculator. Okay. All right. We've got three pretty basic examples here. Nothing too complicated. But for each expression, we're going to try to figure out how it simplifies. Okay. The answer should be a number. Okay. I'm going to tell you that. Okay. We're not going to use a calculator here. You can just kind of quickly scan parts A, B, and C. Each one involves a logarithm or one or more logarithms, and we're going to use the properties that we just learned above to come up with the exact value of each expression. Okay, so let's take a look here in part A. We've got log base 8 of 16 minus log base 8 of 2. Okay, the key here is that these are both the same base. They are both base 8 logarithms, okay, and we're subtracting them, okay? So we have two logarithms of the same base that we are subtracting. If we go up to our properties here, the three major properties of logarithms, okay, look at this right here, okay? If you have two logarithms of the same base that you're subtracting, you can use the properties in this direction, okay? You can go, well, I've already got the red arrow drawn correctly. You can combine these two logarithms into one logarithm, okay? Subtraction turns into division, okay? So this is going to become, okay, let me go ahead and erase this. This is going to become the logarithm base 8. You want to keep the same base or it's not correct. Okay, you have to keep the same base. So subtraction turns into division. This is going to be log base 8 of the first thing, 16, divided by the second thing, which is 2. Okay, so that's, you've turned it into one logarithm. Okay, so this is going to be log base 8 of 8. Okay, and there's a couple of ways you can look at this. Okay, but remember, this is now a just, a logarithmic expression. It's one logarithm. Okay, remember, this is going to equal a number. Do the arrow thing. Okay, 8 to what power is going to give you 8? Okay, 8 to what power is going to give you 8? Okay, that's going to be 1. 8 to the first power is 8. Okay, so the answer here is going to be 1. Okay, this whole thing simplified. Okay, log base 8 of 16 minus log base 8 of 2, it simplifies to be 1. Okay, keep in mind if you were given this same problem, but one of these guys was log base 7 and the other one was log base 8, because you have different bases, you wouldn't be able to combine them. Okay, you can only combine them if they are the same base. All right, let's try part B. In part B, we've got 5 raised to a complicated power. Okay, the power here is log base 5 of 6 plus log base 5 of 7. Okay, let's concentrate on the exponent here because that's where the logarithms are. Okay, so in the power here, we're adding two logarithms and they're both base 5. Okay, so if you have two logarithms that are the same base and you're adding them, you can use property 1 here. Okay, so if you look this time, let's draw right here. Okay, right here. Okay, if I have the logarithm, two logarithms of the same base that I'm adding, we can follow the red arrow this way to the left here and combine these guys into one logarithm of the same base. Addition will turn into multiplication. Okay, so let's try it. We're working on the exponent here. Okay, so this is going to be 5 raised to, we're going to take the exponent and simplify it. In the exponent, we're taking those two logarithms and we're combining them into one. Okay, so this is going to be log base 5. They're both base 5 logarithms, so we can combine them. Okay, addition will turn into multiplication. Okay, it's going to be the 6 times 7. Okay, so this is going to be 5 raised to the log base 5 of 6 times 7. So this is going to be 5 raised to the log base 5 of 42. Okay, that's what that becomes. Okay, so we've basically used the first major property of logarithms to combine these two logarithms into one. Okay, so at this point we're left with 5 raised to the log base 5 of 42. Okay, in an earlier section we talked about how 5 and log base 5 are inverses. So if they're side by side, they're going to cancel. The 42 is going to come down. So that's the answer. Okay, this whole thing that looked kind of messy has simplified to be 42. All right, let's try part C. Okay, in part C, we have e raised to a power. The power is 2 times the natural log of 7. Okay, so let me write this a little bigger. Okay, so again, you've got a situation. We know e and natural log are inverses. Okay, if they're side by side, they cancel. Okay, so you might be tempted to say, okay, they're going to cancel and this is going to be 14. Okay, that's not what's happening here. Okay, there's a little bit of a problem because e and ln are not side by side. This 2 is an issue. Okay, it's preventing the e and the ln from being side by side, so they actually do not cancel as it's written. Okay, let's focus on the exponent. Okay, so the exponent is a number times a logarithm. Okay, so we can use the third property on this. Okay, if you have a number times a logarithm, okay, you can use this property in this direction. Okay, what you can do, okay, if you have, well, let me write it over here. If we have a number times a logarithm, okay, we can do the reverse. Okay, the power's already been brought down, we can bring it back up. So you can move the number in front back up as the exponent. Okay, so this is going to become e. We're working with the exponent. In the exponent, since it's a number times a logarithm, we can take this number in front and bring it up as the power of the 7. Okay, so this is going to be e raised to the natural log of 7 squared. Okay, 2 becomes the power on 7. Okay, now e and ln are side by side. They cancel. The 7 squared comes down, okay, as the number. Okay, and so the answer here is 49. Okay, at first glance it may look like it's 14, but if you correctly apply the properties of logarithms, the correct answer here is 49.